Dear students, in continuation to the last lecture, this lecture is for the derivation of line to line fault, and we have to follow the same steps which we applied in case of line to ground fault. First of all, you have to make the connection diagram of fault or fault diagram. So there is a three phases A, B and C, and the fault will occur between line B and C. B and C is shorted by a fault impedance of ZF. So the current IA is equal to the 0 out from the line. IB and IC are IB equal to, we can say IB equal to the minus of IC. So from this fault diagram we can follow the step number 2. We have to write the equation of the or given condition. So given condition is that IA equal to the 0, IB we can assume that it is IB, and IC equal to the minus of IB. And if we applied the KVL here, the VB minus VC is equals to ZF IB. So this is the given condition. Then what is the third step? The third step is that from the given condition we have to write the sequence component of current and voltage, or we have to draw the relation between the sequence component and phase component of current and voltage. So IA1, IA2, IA0 we know that it will equal to 1 by 3 of 1 1 1 1 1 alpha alpha square alpha IA, IB and IC. IA equal to the 0, IB equal to the IB, and IC equal to, we have write minus of IB. If we solve this matrix, then IA2 equal to the minus of IA1 and IA0 equal to the 0. Then further we have to make the sequence component of voltage. We have to write the relation, the sequence component of voltage and phase component of voltage. So VA1, VA2, VA0 equal to the 1 by 3 1 1 1 1 1 alpha square alpha VA, VB, VC. From the equation we can write the VC equal to the VB minus ZF IB. Now we solve this equation. From this equation, 3VA1, this is 3VA1 equal to the VA plus alpha VB plus alpha square VB plus alpha square VB minus alpha square ZF IB. So if you solve this matrix, this equation, it will become 3VA1 equal to the VA plus alpha square into VB minus alpha square into ZF IB. Similarly, equation number from the equation of VA2, 3VA2 will become VA plus alpha square into VB minus alpha ZF IB. Now from these two equations we can subtract equation number 1 from equation number 2. It will become 3VA1 minus VA2 equal to the alpha VA minus VA8 will become cancelled. So alpha minus alpha square, this terms will also cancel, only this term will remain. It will become alpha minus alpha square into ZF IB. Or we know that 1 plus alpha square equal to the 0. So we the value of alpha minus alpha square can be right, it is equal to the Z root 3 into ZF IB. And the we can write the value of IB in terms of the symmetrical component. IB, what is the value of IB? We know that IB equal to the 1 plus IB equal to the, in terms of IA1 plus IA2 plus IA0, IA1 plus alpha square IA2 plus IA naught. So we can put the value of IA0 is 0, IA2 equal to the minus of IA1. So IB can be alpha square minus alpha into IA1. This equation will come, this value will come from the equation of IB in terms of IA1, IA2 and IA0, which we studied in times of symmetrical component transformation. So the value of IB will become minus Z root 3 into IA1. When we put this value in this equation, that 3 root 3 will become 3. So 3 will become cancel. So and j and j square, it is minus 1. So Va1 minus Va2 will become Zf into Ia. So we get the two relationship between the current and voltage. First is Ia2 equal to the minus of Ia1 and Ia0 is equals to 0, and Va1 minus Va2 is equals to Zf into Ia. So from these three equation 11.1, 11.11, 11.12 and 11.16, we can assume, we can make the diagram, symmetrical component diagram from this given equation, which should be satisfy these three equations. So these equations suggest that the sequence component, positive and negative sequence component, are connected in the parallel and zero sequence component disconnected. If we draw, we can connect positive and negative sequence component in this fashion. This will become Va1 and Va2, and it is Ia1 and Ia2, and it is Zf. On its Thevenin equivalent become Va1 equal to Ea Z1 into Va1 and Ia1, Z2 Va2 is Ia2. So we can cross check our equation from this diagram. From this we can say that Ia1 equal to the minus of Ia2. This equation satisfy Ia1 equal to the minus of Ia2. Ia0 0. There is no connection between from the zero sequence component. So Ia0 is 0, and Va1 minus Va2 is equals to Zf Ia1. So this is the voltage Va1, this is the voltage Va2. If you apply the KVL here, Va1 minus Va2 equal to the Zf into Ia. So our equation will satisfy from this diagram or this connection. So this connection, if we get the connection, then the calculation of the fault current or fault parameter will be easier for us. So from this diagram, we can write the value of Ia1. Ia1 will become Ea, this is single voltage or voltage source here, Ea, and impedance Z1, Z2 and Zf. So Ia1 become Ea plus Z1 plus Z2 plus Zf. If we get the value of Ia1, then Ia1 equal to the minus of Ia2, and Ia0 is 0. So Ia is equals to Ia1 plus Ia2 plus Ia0. So Ia is 0. Ib, we can get the value of Ib, we can get the value of Ic, and also we can get the value of other parameter. So Ib equal to the minus of Ic is equals to minus j root 3 Ea upon Z1 plus Z2 plus Zf. Or other parameter Va1, Va2, Va0 we can also get from the diagram. So this is all about the line to line fault. So in the next lecture, we will make the derivation for the double line to ground fault, LLG fault.